Hello. Hi, Narud and Herb. Nice to see you in chat. It's not the Chill Math stream. I'm James. Hi. The idea is that this is a bit of Chill Maths at the weekend. It's the 17th of December. This might be the last time I do this in 2023. We'll find out. Hello, cool. It can be people a moment. My plan for today, like pie. Oh, and I toast potatoes is here as well. And Maria Return. Oh my goodness. Hi everyone tuning in. Bang on 2 o'clock. It's very exciting. Here's my plan for today. Shouldn't be the whole plan, I guess, but part of my plan is somebody told me that Desmos can do derivatives. I want to find out what's going on there. So, like, you have what equals x cubed minus x or something, and then someone told me you can do d over dx, and then I think you have to type it again. Yeah, if you just do d over dx of y, it complains. But if you type it again, then you get the derivative. It does lots of derivatives. I'm not sure how far it goes. I'd like to understand that. Hi, Super Snowman, and yes, I toast potatoes again. I need to not say hello every time someone puts something in chat. That'd be too much. Yeah. Oh, so see, if you say f of x, then it's good. Okay, let's give that a go. So I think I want to try and push this. So it's not happy with that. But if I name it f up here. Oh, you can do f prime if you call it f. Right, if you give it an argument. Okay, that's interesting. So you can do that, but only if you type in f prime of x. And then it's got something different, right? What's this purple thing? If I confused it. If I call that f of x. Yeah, okay, so there seems to be some real fundamental difference between whether I call that f at the top or f of x. Okay. In the purple one works. If I put f of x in here. Okay. Now the purple one does. Oh, the purple one does work, but it's underneath. Derivative. Okay, so it seems like the way to make Desmos happiest is to call this f of x. To do derivatives like that. Okay. Can I give that a name? So if I want that derivative to have a name, I think this might be helpful for like visualizing things. I've got this plan of a problem that I want to talk about, but first I want to make sure whether I can actually do anything in Desmos. I was at an event, just a quickly in-person thing yesterday, where some people asked me what the hardest maths in the course at Oxford is. I didn't have a very good answer, so I need to work on my answer for that, I think. Okay, how are you doing in chat? You all right? Sunday afternoon. We've got some maths on screen, but so far just polynomials. My plan is that I would like to be able to do things like this with 2 arguments in, right? And I'd like to do kind of derivatives with respect to x and with respect to y. If you've read ahead a bit, then at university you learn about these things called partial derivatives, where you have functions of multiple variables, and you see what happens when you change each of the inputs. It's a function of x and y. What happens if I change x and y separately? Now I reckon Desmos can't do this yet. We're going to get there. Not f's like that. dx. I reckon it can't do this, but we'll find out, I guess. Yeah, it's unhappy. Function f requires only 1 argument. That's going to be a real problem for today. Can Desmos not do functions with 2 arguments? Can I hack it? Can I hack it? Return's doing good. I'm alright, thanks. Just did a little bit of weekend hoovering. I thought I'd do some household things. Did about 2 minutes of hoovering before the Hoover broke. Opinions are divided on whether I broke the Hoover or not, and if so, whether it was to get out of doing the hoovering. But yeah, Hoover's now broken, so that's enough household tasks for the weekend. That's me. The suggestion in chat is that I just learned GeoGebra. Is this suddenly a GeoGebra stream? There's something neat about forcing Desmos to do things that it can't quite do. For example, it can do lists, right? So if it had like something like a is x squared comma x cubed, then I think you could have f of a equals, you're gonna not plot that. No, I don't really know. Can it do a of 1, a of 2? I don't think it can. Ooh, hang on. Oh yes, it can. Okay, so it can do a indexed along the list. Ooh, there's a link in chat. Let's open just random links. Wait, this is great. Okay. This is the Desmos thing that I've been showing. But someone's just gone for a dbdy. Someone's gone straight for dbdy. Does that just work? You could just dbdy things. They've got a function. They've got a function of two variables and Desmos has not complained at them. I suppose I don't have any definition on my right hand side. Oh yeah, I asked it to differentiate something without telling it what it was. Okay, that makes it happy, does it? I'm not happy with that. What precisely have you done? This other person has done just dbdy and then plotted it. Why is that not working for me? I've got different numbers of brackets. Why won't it even let me do dbdx? What's the error message? I've got too many F's going on. This is fun, isn't it? Real learning experience now. What does it not like? Still doesn't like it. Too many F's. Happy now? Try adding x equals. Oh, okay. I've got to give it a name because that's of course a function for the derivative with respect to x, and then I can plot things like that. Okay. Then you can plug variant numbers in. Okay. 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 So the other challenge we've got is that you can't visualize functions of two inputs, functions with two real inputs in Desmos very easily. So I guess the two stages I need here in order to visualize some partial derivatives. This person, whoever they were, have done a great job of showing me that you can just do derivatives by differentiating with respect to each letter. This says, what would happen if y changes a little bit? For this function, it's a pretty complicated question. So to visualize this, maybe I also need some sort of so to visualize this, I think maybe I also need some sort of a vector field thing, which I'm sure other people have done, but I'm going to give it a quick go, I think. Yeah, how hard can it be, right? So the idea would be something like, you've got a, that says I'm offline. Well, that should be pretty bad, but it's just Miro being Miro. You try now? Maybe I've lost the internet. I can actually see in the Twitch window the preview of Miro telling me I'm offline. Thanks, Miro. I think I want like different points at different points in space to show little vectors. Can't quite work out how to do that yet. We'll get there. I guess I've seen people do like arrays of stuff, right? So you have like how do you do any lines in Desmos, right? How do you do little vectors in Desmos? Can you just do like line from no plot? Quick check. How do you do lines in Desmos? So it's not a good start. I want to do line in 2-point form. Oh no, that's terrible. Who's made that? Just want like a little line segment. I'd like to plot some line segments. Little line segments. Desmos is definitely not the right thing for this. I should probably learn GeoGebra at some point. We're going to learn GeoGebra at some point, I guess. Some point in my life, I'm going to learn GeoGebra. Okay. So I think you can do this as like a parametric plot. I just saw someone try this. We have like a first point and a direction. But then you need to convince it that it's going to draw that for... Yeah, so it wants them like this. 2 plus t times 3. So that it's got... Yeah, okay. So then it's got this kind of t parameter where it's showing me these for t between 0 and 0.1. And that's how I'm going to trick it into showing me little lines. But I need loads of these. So my plan is to show... to try and visualize functions of multiple inputs, and functions with multiple outputs. You might think about the inputs as points in 2D space, and you might think about the outputs, if they're 2D as well. You might think of those as tiny little vectors to show which direction things are going in. People in chat, where do you think I'm going with this? What am I trying to build? I thought it'd be fun not to say, so that so we can get there when we get there. So to do a few of these, you could have something like a list of x coordinates and a list of y coordinates, and then a list of direction coordinates. So if you want them all pointing up, there we go, 0, 0, 0, 0, and oh gosh, I hated that. It spotted that that was the name of a variable. Subscript variables. You have something like this, and then you've got lists because Desmos does list comprehension. So you have like your XA points plus the change in x, which I've called dxa, multiplied by t, the ya list plus t times dya, and that was, there it goes, so just briefly. Okay, so this is little line segments with different magnitudes starting at different points. So I can start them at different points. This controls where they are. And they can go up as well as left and right. And I suppose I want these directions to be not just 0 and 1, 2, 3, 4, but I want them to say something about the... be in terms of x and y. That would be quite nice. Can I make them be something like XA? Yeah, okay, so I can just use reference to the X and Y. So this is going to be good. This is going to be good. Yeah, okay, we're already getting somewhere. So I can have them take the coordinates for wherever these random points are. I guess they're not random, but whatever. And go to town with that, multiply together the numbers. Let's divide them by 10 to make them a little bit shorter. Divide both of these components by 10? Yeah, no, of course, I can set... these things can be different. Oops. Do squares or something. Okay. So this is showing us there are components everywhere. And this is only 4 kind of pretty close together points. But this is showing us at 4 different points 4 little vectors. I'm going to make them a little bit smaller, I think. Can we put this scale factor or something for if the vectors are looking too large and it's getting confusing? Yeah, so I want to set scale somewhere between 0 and 1. It's going to be down at somewhere small. Oh, it's making them larger because I multiplied. I want to set scale to somewhere between 1 and 10. Make it large. There we go. Okay. So we've got little vectors, little line segments for the points at different places. 5 minutes to get to the point. Maria's given me 5 minutes to get to the point. Can I set a timer in Twitch? Is that a thing? I can't see it in here. I can run an ad break when I come back from the ad break if I got to the point. Okay. So this is good. It's so far just a row of points, but I reckon I can get around that by setting up XA and YA to be really clever. For example, these could be 1, 2, 1, 2, and this could be 1, 1, 2, 2. And now they're at the corners of a square, and they're showing on a little grid. Desmos doesn't really do meshes of 2D points, but if you just list all the points that you want vectors at, then maybe it can do that. Okay, let's go a little bit wild with this. How do I want to do this? What next? I think I want to check what negative numbers look like quickly. Hey, that's quite nice. So -1, -1. Keep the y's up there. Hey, okay, so over here, my XA, YA thing, the x component of the little blue vectors is pointing to the left, but XA squared plus YA squared is still positive, so they're still pointing up in the Y direction. I have these kind of directions. There's like two components, dXA and dYA. So we scale to the top as a parameter. This plot can go anywhere, I guess. Quick settings. Just one of those things, right? Okay. It's still a bit random. I think I just want loads more points. So I want to make vectors like this, but across lots of points. I'm going to try and work out how to do that now. So what do I want? I want this to be something like 0, 0, 0, 1, 1, 1, 2, 2, 2. So the stupid way to do that is to type 0, 0, 0, 1, 1, 1, 2, 2, 2. I saw people in chat doing I saw people in chat doing Advent of Code, and that stuff's way beyond me. And then I want this to be 0, 1, 2, 0, 1, 2. And now I've got to be a bit clever. A comma 0, 1, 2. Okay, so I've got my little grid of points, but I want to generalize this so that instead of doing all the typing for where these points are, do something a little bit different. Let's turn the scale up a bit. There we go. Okay, and I'm bored of this function. I would like a more interesting thing. Something like... Let's just set them to XA and YA for a bit. It's a little bit confusing, isn't it? Oh, it's not enjoyed that at all. There we go. Okay. Oh, it's going to be a sort of explosion picture or some sort of perspective drawing. Nice. Okay. But I want this to be much better. I did a grid like this once for... True Say tiles. There's a trick for it. Something like... These are the first digits of... These are the digits of 0, 1, 2 and then carry. It's like trinary. So if you extract your digits from numbers by doing something like n equals 1, 2. So Desmos does do list comprehension really well like this. That's the list of numbers from 1 to 100. Now what you can do is you can do, to do mod n. Yes, it does mod n10. Can I get it to repeat that? So that'll be a sequence that goes, let's start at 0, come on. Chat will be cross if I don't start at 0. So that's the sequence that goes 0, 1, 2 up to 9, and then 0 to 9, 0 to 9, 0 to 9. So that looks really good for Y. Not quite sure what I'm going to do for X. Oh yeah, it's going to be something like n minus mod n divided by 10. All over 10. So let's put that up here. And let's put that up there. Put that up there. It's really cross with me. Why is it cross with me? Function mod requires 2 arguments because I have to put the comma 10 in. Oh, hey, there we go. Okay, now we're getting somewhere. Now we're getting something where we've got a big grid of points. Big grid of points, and we've got some vectors on there. Like a lot of things in Desmos, it gets better when you start putting more points on it. Here we go. Okay, they're all positive at the moment. We can fix that nice and easily by just putting a translation on these. So I can just take off 5. Where do we get up to? We get up to 9. So I'm going to take off 4. Yeah, okay, that's good. And take off 4 from these as well. There we go. Okay, we've got a nice little grid of vectors. Didn't take that long at all. So the vectors here have each got components. And at the moment, the components are just kind of plugged together. So I hate this scale factor at the bottom. I'm just gonna invert that. Wow, emojis in chat. Oh, well, that's gone a bit weird. But the idea is really that we're going to put more interesting functions in here. And I think I've now got, yeah, and I wanted this to be between 0 and 1 because I think that makes more sense. And I've broken it. Why have I broken it? It doesn't like this. Like if I put a space in. Okay, put some. I am allowed to put spaces in. Great. Thanks, Desmos. Okay, good. More interesting functions. Let's go. So, have I got Myro? And Myro now thinks I have the internet. That's nice. The thing I want to do with this, 5 minutes, Maria, mark the time slot, is I've been talking to people about fluid flow and trying to visualize the kind of flow around a circle. Now, fluid flow is hard to visualize because you need to have vectors at points in space, and that's tough because you have to show a vector field, field in the sense that it's like you look at a field and it takes up 2D space, that kind of field, not the sense that you can divide these things except for the zero element. But we've now got the technology to visualize those things in Desmos. At the moment, this doesn't look like the flow past anything, but there's a trick I know where the right thing to do is to take basically this flow all going to the right. So let's put that in. That would be 1 and 0. Okay, that's like the flow going past our circle. And then you add a thing. You add just the right quantity. And I know a way of working this out. Yeah. Thinking of that green bean mathor. The what? There's a trick for this, which is that you can consider vector fields of the following format. Vector fields that are themselves. Let's turn the thickness up. What's going on here? So if your field is itself the derivatives of something, which is very hard to explain, really. But you start with some function of x and y, and then you calculate some partial derivatives. So this says, imagine how your function would change as you changed x, and the second one says, imagine how the function would change as you change y. And those are kind of two different things, so you end up with this kind of vector of two different concepts that you could calculate. But it's kind of a little bit easier to think about because you just start with one scalar function that gives back just real numbers. This thing takes real numbers squared and sets them to reals, and then you end up with this function from reals to reals. The trick is that the inviscid irrotational flow, which let's not worry what that means, we're just looking for functions that satisfy a particular differential equation. Differential equations in this context means you take some derivatives and then some things together. Is there a VHart video about flow and derivatives and vector fields? I bet there is. My aim here is to try and get it all working in Desmos. So my kind of two-step plan was to do a bit of this with partial derivatives, a bit of this with vector fields. This one currently looks really boring, and then try and combine them together. Okay, here's the trick. We need a little bit of understanding to understand what this means. So this is irrotational. So if the velocity is this, then irrotational inviscid flow. These are some rules of the game for the sort of fluid that I'm talking about. It's not, and the sort of initial conditions I'm talking about. It's not super important right now. Most important step is to look up del in cylindrical coordinates on Wikipedia. Everyone I know who does a theoretical physics PDE's kind of PhD at some point bookmarks this page, which is the Wikipedia page, which tells you how to do derivatives in different coordinates. What do I need? I'm in cylindrical coordinates because I've got angles. And these formulas are really hard to remember. So everybody I know has got this page bookmarked. Yeah, 1 over r divided r divided r inside. Right, I think I kind of knew that one. It's the classic use of this page, right? Is to the classic use of this page is to look at it and go, yeah, I think I sort of remembered that. Good, okay. 1 over r divided r. This is what it said. That's not right. Back up. The plus operator. Oh yeah, I missed a derivative. R divided r. And this is t25 theta squared. This is worth it, I promise. Without this bonkers, weird symbol stuff, I think I'm going to get to some sort of cool looking flow. This is something you do at like university fluid dynamics courses. You then go and solve this and work out what the flow is. I'm not going to step through solving this, but you can find this kind of interesting flow, which is just a function of r only. So instead of thinking about functions of x and y, overall, big general class of things, you can think about functions that are just functions of x squared plus y squared. Like you say, I've got two inputs, I'm going to sticky take them together, x squared plus y squared, and then just think about functions of that variable. It's kind of an easier case because then, well, this thing's only got one input, so now your partial derivatives become actual derivatives, which is kind of nice. And then the solution to this just becomes solutions to this. Ignore null, which would be there's like the solution phi is a over r, which I quite like, and I think I would like to try and investigate what this one looks like. I've got this feeling it's useful. I can't quite remember why, but I think it's useful. I think it balances out the flow in some sense. So I'd like to plug this back in, I think. So this says we should be looking at maybe 1 over x squared plus y squared as my function. But the function only exists in Miro. On this terrible like back of the envelope scribbling that I'm doing, that's where I've got my function phi. Desmos doesn't know about phi. Desmos just wants me to give it some functions, which in the Miro world I believe are like my derivatives. So I need to do some derivatives of this, which means thinking about how this changes as you change x, keeping y constant. Well, that's not actually too bad. If you treat the y as constant, then this is the sort of thing you differentiate like at A level or whatever. He says, getting it immediately wrong. It's like this, it's not too bad. So we can put that in. If I do y is... Yeah, am I doing the right thing? I think I'm doing the right thing. This, it's nice. I think that might be interesting. So I'm going to give it a go. I'm going to stick it in Desmos. This is the next thing I'd like to plug in, right? These components. 2y, 1/2, minus signs. Do I care about the minus signs? No. Okay, let's stick it in and see what happens. So this is going to go through some really weird shapes along the way as we get there. Each time I type half of one more character, it's going to be even weirder along the way. It's kind of doing something really spotty and weird, which is a bit even weirder than I was expecting. Okay, that's really hard to see. Not sure I like that. Come back and think about this in a second, I think. Yeah, it's all going outwards. Why is it all going outwards? Is that what I wanted? No. I was hoping for something more round and round. Yeah, there was a shape in there that was more interesting than the place it ended up. What was I hoping for? What was I hoping for? This is not too bad, right? Sort of explosion thing. There's more explosion in the middle than it is on the outside. 5, 6, 7, 8, 9, 10. This is annoying me. It's out by 1. Ooh, okay, the ones closer are definitely much larger due to this factor of like divide by distance to the 3/2. Why was I expecting so many theta? Oh, was I thinking about stream functions instead? Maybe I was thinking about stream functions. Yeah, this one doesn't have... What am I doing? Let's try switching X's and Y's and see what happens. Oh, that's quite nice. Okay, here we go, here we go. That sort of twisting thing going on. These points are all going round and round. Is that what I want? I kind of want... it's a little bit hard to see where the points start and stop. Maybe I don't care. But twisting around. It's kind of nice. Oh, that's a bit unfortunate. Back it up. Yeah, it's a whirlpool thing going round and round. I'm not really sure if these are all obeying the fluid flow equations. I haven't been doing this very carefully. Yeah, let me have a quick Google of the thing that I'm trying to show you. Yeah. Ah, it's got an entire Wikipedia page. Let's come back to this. What am I trying to do? Oh, I'm trying to do the next one up. That's annoying. Wikipedia says that I need to look at more interesting modes. So the one I was looking at before I started switching things, putting minus signs on stuff, was just outward flow, which is not very exciting. Things exploding out from the middle. I'm looking at a clock to a whirlpool. Yeah, I know. That's good, isn't it? It's round and round. There's this really funky parameter I've got here. I'm going to switch it back again. Whoops. So sometimes it likes to actually plot it, and I don't know why. I want this to just be a kind of helper function where it's calculating a thing, but occasionally along the way, Desmos says, "Oh, I can plot that," and then it tries to plot that, which also it simultaneously messes up the other thing that I'm trying to plot, so this green thing on top. Okay, hang on, right, so back again. There are more interesting solutions out there. So if I don't ignore that term, because actually this calculation that we did from here down only found us this solution. It didn't find the one with all the flow going past that I started with. Which is this one. I kind of want to rediscover that, I think, for flow going past. Partly this is doubling up that I want to do. I want to do this a bit because I just think there's something good in here. Try out content. When I don't do the subscript, it tries to plot it. Yeah, if it sees any X's and Y's, Desmos has got strong feelings about the letters X and Y. You know, if you type W, it's fine with that. If you type T, it's something interesting to tell me more. If you type F, it's fine. If you type X, it's like, aha, plot Y equals X. It's all sort of, it's just about to type xylophone, right? You know, it's not. Gets very excited as soon as it sees particular letters of the alphabet. Well, the other ones, it's also got strong feelings about R and theta. Anyway, favourite letter of the alphabet, chat? This can't go wrong, right? I found out Twitch doesn't let you make emotes that are a single letter. I made some really nice, like, this plan to let you have like these as emotes, but Twitch was like, no. People might spell things with those, so you can't have them. I didn't give you any vowels, but they still, yeah. Yeah, well, I kind of meant English alphabet because that's what the joke was that Desmos has a favourite letter of the English alphabet. I'm going to go Aleph. Can I draw an Aleph? Let's find out. I wonder if Twitch's no letters policy extends to Hebrew alphabet. I'm not very good at drawing that at all. I wonder how. So Wikipedia has this symbol, like this. want to have people in chat draw this symbol, if you have to. You're talking about infinity. The continuum hypothesis. Brilliant, good, okay. Oh, goodness. Delens, spherical and cylindrical polars. Not fun. Right. Ask my friends. This was one of the questions for nerds, wasn't it? When you gave me some questions to ask people at a party, and then I didn't report back. They had to choose between pi and phi and e or something. They all picked e. Anyway, good job. I was talking recently with someone about how when you're teaching students, they love to swap the letters to familiar letters. So if you have like some functions, people would like to write them all as y as a function of x, whatever they are. Desmos is a bit like that as well. What is that next to your username? It's got a little 2023. It says Twitch Recap 2023 when I mouse over it. There is LaTeX in Twitch chat extension, but you haven't tried it. Oh, do you have to install an extension yourself? Your shelf? Do you have to install it yourself? You can't just go. Right, so like you're telling me this won't work. It did not work. LaTeX and raw tech underneath. It's pretty good, but that is the best way in raw tech to do the fraction 1/2, which you sort of feel like you could have had a symbol. Oh well, okay. So how much of this am I going to show you and how much am I just going to do? I think I'm going to look for solutions like f of r cos theta, because I've got this problem, right, that I'm trying to find the flow around a circle, and my first guess of just the flow ghosts through the circle like it's not there. This is rubbish, because on the surface of the circle, where I would like the thing to be going around the circle, instead I've got instead of that, I've got this flow, which is, what is that? At a point over here, right? So trigonometry time. Trigonometry to try and justify a thing that I know I'm about to do anyway. It's on here. At this point over here, there's some kind of, I guess, what is this? Tangential component will be fine, but there's some normal component. The normal component of this vector is something like, so I need to drop a theta here and a right angle, and oh my goodness, the normal component is, it's got to be cos theta from whatever this vector field is. So if this is u in the x direction, magnitude u, then this is going to be u cos theta in the normal direction. When theta is 0, that's all normal problem. Up here, when theta is pi over 2, that's like still u in the x direction for the velocity, but it's kind of fine. Okay, so if I try this and I plug it in, then I get that's going to find 0 becomes something like I've got to do an r derivative of r times another r derivative, which has got a cos theta in it, and I've got to do 1 over r squared here, 2 theta derivatives, but the 2 theta derivatives not too bad. It just gives me back cos theta, which gives me hope that I could actually solve this thing, because here we go. The cos theta is going to be on every term involves cos theta. So either we get lucky on theta, or if we want to solve this for general theta, any value of theta all at once, we're going to need the coefficient 1 over r, dB r here. It feels weird calling it a coefficient. I guess it kind of is, and be this, which would be f prime over r minus, so differentiate the first term, product rule, second term, this is a bit of a mess, which has got solutions which you can find by, so this is a horrible differential equation, right? Let's focus on this a second. This says if I tidy up the minus signs and bring terms together, this says that you've got you've got a function of r that we're trying to find. And this is the second derivative. Take away the first derivative divided by r, plus just the function divided by r squared is supposed to be 0. There is a nice way to solve things of this form. Just to try f equals r to the n. It's worth a guess, right? Before you try anything else. And then there's kind of other stuff going on here as well, but let's not worry about it. We end up with something like n squared take away 2n plus 1. It's pretty good. Is that what I wanted? Not at all. Not at all. Do I love all these minus signs? I do not love all of these minus signs. What was I hoping for? I was hoping for n squared minus 1, I think. Why have I not got that? Geomaths, where James tries to remember things that he learned a long time ago and get the calculations right without really trying. Ooh, it's the jingle for a show. This show. Why is this being all r and r log r? I don't want any logs. Did I swap some minus signs around? Wouldn't be the first time. I thought I swapped all of the minus signs. Ah, there's a plus here, isn't there? I didn't do the product rule right. Geomaths where 8 is a prime number, as evidenced by the sum of its factors being 9. That's how you can tell. We're fixing minus signs, fixing minus signs, fixing minus signs, fixing minus signs, get cancellation, and exactly the thing that I wanted. We get these two functions with n equals 1 and n equals minus 1. Okay. We're good, I think. Because this gives us two interesting functions. They are, phi is r cos theta, which we've kind of already looked at in a way, and phi is 1 over r cos theta, which we haven't looked at. We looked at what would happen for 1 over r, but not 1 over r cos theta. So this is going to be a different function. Now each one is a little bit tricky, but this is in sort of polar coordinate stuff. That's just x. This is x over r squared, I think. X would be r cos theta. It's divided by r squared. It better be this. It would be like x over x squared plus y squared. So challenge is to work out, given phi is x over x squared plus y squared, I would like divide by dx and divide by dy. I'm trying to set this up so that I can give it to Desmos. And Desmos, I think, can maybe do the partial derivatives. That's a challenge. Stick it all together, right? We're going to do this one the sensible way, and then I'm going to break everything and stick it all together. So there's like some product rule, quotient rule stuff going on here that I'm probably going to get wrong, but you know, geomaths. They drop a factor of 2x from the derivative, put a minus sign on it because it's downstairs. That could be worse. Could be worse, right? So it's that y squared minus x squared over x squared plus y squared squared. Handwriting, not the strongest point. Oh, zooming. Not what I needed to do. Divide by y is a little bit easier, right? It's just 2xy over x squared plus y squared. Okay, cool. Which reminds me, whenever you see this like y squared minus x squared 2xy pair, it's supposed to make you think about complex numbers. Complex numbers are full of like this, like, what's going on here? Complex numbers are going on here. These are the real and imaginary parts of something like x plus y, no, x plus iy squared, but divided by the modulus of the thing squared. I don't know. There's some really imaginary parts going on. Worried about that squared? No, it's fine. It's fine, right? What did we start with? 1 over x, and now it's supposed to be squared over here. Good. Okay. So let's hopefully translated it into a format where I can put it in decimals, and we'll see what happens. Y squared minus x squared over x squared plus y squared, 2xy over x squared plus y squared. Right, let's put this in decimals, but I've got to remember that I want. I've got to type A's underneath, otherwise it does that. Fraction mode. Thank you. I find it's good to enter fraction mode early, otherwise Desmos has opinions about where to put your fractions. I do quite like the things that it's drawing. It's also not great at, there we go. Ya squared. Let's hit that to the power of 2. That's already a bit weird. Ooh. And then over here, instead of 0, we want 2 times xa times ya. And that's created a huge mess, so that's nice. No, seriously, what's going on here? If I drop some minus signs, probably drop some minus signs, just going to come back. It should be much nicer than this. This is horrible. Don't wow at this. What is even going on? Oh, it's got really negative over there. I don't like the way it's all crazy directions around here. Wow, horrible. Kind of acceptable outside, not so acceptable inside. Right, double check. What was I doing? I was doing this. Is that not x over r squared? R cos theta really is x over r squared. Yeah, I think I just differentiated wrong. Wouldn't be the first time. Minus 2x. No, I like this. R squared minus x squared. Yeah, I'm still with that. Nope, still think I differentiated correctly. Don't wow that. It's a mess. Look at it. It's horrible. This bit's going different direction to that bit. I think it's probably an accurate plot of the thing I've given it, but not somehow not the thing that I was expecting. Let's stick a minus sign on that. Should be possible just to do the x and y derivatives. I've squared everything. I've put the denominators correct. A minus sign in it, see if that fixes it. No, that's made things much worse. I was just expecting this to look much nicer. Just think about visualizing stuff, right? You actually find out what it looks like. Why is that so hideous? Why is it like this? Okay, let's try moving these points in a bit. That's divided by 2 afterwards. Positive and negative are flipped. Oh, if I flip positive and negative, that'd be good. If I flip them somewhere else, or if I flip them in my derivatives. Ah, this is good. Chat's helping. Chat's going to fix it. Really thought I'd done the x derivative correctly. Have I done the x derivative the wrong way around? Not flipped. No, no. What do you mean? In the graph? Oh. Weird. It is weird. Not sure what I've done. This term just doesn't look right. I've got some weird minus signs in my graph. That'll be a good time to find weird minus signs in the graph. Ugh, why is it so horrible? Why is it going up on that line there? Shouldn't it be going? Cos theta x over r squared. Yeah, it should be x over r squared. What's r squared? X squared plus y squared. How do you differentiate? You differentiate like this. It's alright, neutrino, neither do I. I don't know what I'm doing. Welcome back to Chill Maths, where up is down, right is left. This function is horrible. Is this the right compensation factor? There's a suggestion online that this is the right compensation factor to me. You can just stick like a 1+ in here, and then you get the flow. Oh, it doesn't look terrible. Looks quite bad. 1-. And then, way, we've got the flow around something. But it's dipping down and then up again. Shouldn't it be going the other way? Like that? That's made it worse. Because now it's dipping down before it's even got to the thing. Or are these all... Yeah, no, it's dipping down. The crissy-crossy stuff is pretty weird, but I think that might be inside the circle. So I'm not super worried. Is d by dy, isn't d by dy negative? Ooh! Yeah, that's right. There's a minus sign because of the 1/. I'll take that. I'll take that. Yeah, I'll take a minus sign. Get rid of the 1+ for now. Minus sign. Everything changes. For just a little bit. Okay. This looks a little bit better. Ish. I don't know what I was expecting this to look like really. Not this. This is really weird. This is super weird. And the suggestion online is that you could add 1 to this and it becomes beautiful somehow. It's the flow around a circle. It's on the circle, this is this direction. On the circle, x² + y². This is, well, no, this is horrible on the circle, right? This is like cos 2 theta on the circle. First step of sketching a function in Desmos is to work out what function you're trying to sketch. Maybe this is good. Maybe I only want this where... So let's make some changes to help with the visualization by only plotting it. I'm worried that the ones near the origin are really horrible. So only plot it like that. And only plot... Well, actually, let's ignore all of the correct ones now. Maybe this is good. Maybe this is good. Show me the circle. Okay, so we've kind of got no points anywhere near the circle, which is not great. Let's fix that by moving all of the points. We've got all our points really far away. Let's divide everything by 3 or something. And divide all of these by 3 as well. Loving that grid, by the way. The grid's very helpful. And then bring down the scale factor. Oh, this is looking a bit better. Looking a bit asymmetric and weird, but is this good? Yeah, this is kind of plausible for the flow around a circle. It's not very good visualizing. Yeah. Ignore the points inside the circle. So inside the circle is a bit weird. Can we visualize that? Or is it just going to blow up in my face? Bang! Inside the circle is terrible. I have not visualized that well at all. Outside the circle, we've got this going on. Do you know what? I think this is starting to become a good visualization. It's not quite there yet, but it's getting better. If you want arrows instead of lines, you can use VX. Does Desmos do arrows as a built-in thing? Ooh. I can find other people who have done Desmos arrows, but they're all very, very custom. So the way I do arrows, I think, is something like I would start at this point, and then, oh my goodness, this is going to be awful. So here's the arrowheads. They're currently blobs. V subscript X. People in chat are saying V subscript X. I don't know how many V's. Everyone in chat saying V subscript X. People found somebody else using some sort of v subscript x thing. Now what you want to add on. So you can use a T thing again here to draw a line from the tip of the arrow. These should be little line segments, right? They should be going back in the same direction. 1/3 of the way. And those are not rotated at the moment. Oh my goodness. They should go back 1/3 of the way. Oh, I guess there should be a +T as well. And that should be... So it's now colouring in most of the arrow, because they should deviate from the position of the arrow as well, right? So you should add, that's not quite the direction I want them to go. I also want them to go a little bit in the normal direction, which is, goodness me, something like, we'll take normal direction. So I'll take this thing and add it here, and I'll add this thing times T over here, but change that component like that. And now we're going a little bit away in the normal component. Let's change that parameter to a 5 for how far away we're going. Okay, that's not gone very well. Some of these are a bit off. Why are some of these a bit off? Some of my arrows... do I want a normal vector somewhere? Maybe. They're not perfect. Oh, the smaller arrows have got smaller arrowheads, but I thought I allowed for that by just putting it as like dxa over 3. So it would go back 1/3 of the way. Why is it not going back 1/3 of the way? Let's go back, what is that? 1, 2, 3, 4, 5, 6, 7, like only one box out of 7? Oh, because it's trying to add on some YDA. Time to play with minus signs. Minus signs, minus signs. Time to play with minus signs. Yep, plus and minus. Yep, good. Okay. Okay, almost there. Copy this. Some ideas about normal directions in there. Flip the direction of this like that. And like that. Yay! Make them all blue. They're arrows now. Chat, we made arrows. Anything's possible with vectors. We did it. We got a little vector. We got a little vector field. There you go. This is how people normally draw vector fields with little arrows, right? Hooray! I've got a bit of a problem that the longer the arrows get, the larger the arrowheads are. But I kind of like that. Well, I like letting go really small. There we go. Flow around a circle. Okay, this visualization is getting better. I'm actually getting excited about our ability to show this. I want to make a lot more arrowheads, I think. So I'm going to switch a kind of master parameter here for like the width, end width. So I regret typing the number 99, right? So sort of 10 in here, and that's going to control this number here. I regret this parameter already. I'm going to call it capital M, which I think I'll regret even more in a second, but you know. And then that's good, right? I can just change this to 20. So is that it is? Change this to 20 and it'll be happy? Well, no, that's not exactly happy, but look at all the arrows that's put over here. Why has it put so many arrows over there? Ah, because this 10 is hard-coded in here as well. Sort of like it. But what's the flow like way downstream from the circle? Okay, just making them arrows has already made this so much more interesting. You've got this flow, you've got this acceleration and slowing down again around the other side. Good, maybe Desmos can do this sort of thing. Are we 1 hour in? 1 hour in. Thanks, Maria. What should this be? Like M over 2? It'll be out by 1 again. Thanks, Neutrino. 2 seconds while I fix this parameter to be that, and the translation hasn't quite worked. Why is it so wide? There's some 10s hiding in here somewhere still. It's still really keen on being right by us, right? Remember hydrators for you. Yeah, we made it more expensive because I found out how many channel points everyone had. In particular, Larud, I found out that some people had the ability to redeem hydrate like 8 times in a row immediately, and there were multiple people like that, and there was a kind of drowning risk situation. Yeah, so I thought about 256. Maria's not enough channel points to redeem anything. The redemptions are not that exciting. You can save them for voting in polls. There's a kind of voting thing we can do where you get to put channel points. You can do what 14 times in a row? You've been betrayed that you can only redeem hydrate 14 times. Well, it's nice to know that. Nice to know that people are making sure it's here. That's where it is. There we go. It was a hidden 10. You could probably see it at home. I can't remember if I've got a time limit on hydrate. I probably should. Whoa. Oh, I'm having a great time with that. This one scale slider is really fun. So it's sort of if we set it to like this. I guess what this is showing, by the way, is what would it look like if some stuff that you dropped in the flow flowed past it? Oh, there we go. Oh, that's lovely. That's really good. Let's do that again. This is why you do it in Desmos, because you get the automatic ability to animate things. So you can see where the flow is fast and where the flow is slow. Sort of. You can see it move. Fluid dynamics with moving things. That's just what we came for. It's a shame I didn't get that in before the 1 hour mark, right? Would have been a good point. Right. We've now got a way to visualize fluid flow. We're getting there. Does this work? So let me just check this is mathematically sound, right? The arrows kind of overlap a little bit, which I don't love, but you kind of get the visualization, I think, that far away, things are just all moving uniformly. And they are moving. They're moving like tracer particles that have been dropped in the flow. And then in different places, they're going a little bit faster around. You can sort of follow. You can't quite follow one to another, right? You kind of need more arrows. You kind of need more arrows. Okay, quick vote. We can go 2 directions here. We can either try and do other flows. So I've currently got the flow around a circle. We can try and do other flows, or we can try and stick more arrows in. What am I kidding? I just stick more arrows in, just putting it up to a 4, right? It's less happy now. It's much less happy. Yeah, that's ruined everything. I love that you can edit it live while it's going. This should maybe be set to M as well. This is something to do with M. It's like a M over 3 or something. So we've got, which is a bit stupid to put fractions inside fractions, but Desmos is happy, so we're happy. And then all the scale needs to change. And I regret the factor of 3. I think I should maybe have made it 2. That's much, much worse. If you get the arrows too close together, then it becomes a bit hard to see. Can Desmos animate that? That's quite good. We need to turn this down a tiny bit. And it's got a little bit choppy, hasn't it? Yeah, so I thought more arrows, and then I thought they would just be easy to do. And actually, I don't love it because it's gone quite choppy. I liked that really smooth, fluid kind of thing that we had going on like this, where it was just sort of, you could see all the 400 arrows moving nicely past that. Good. Okay. I said vote. I lied. Okay, let's try. We can try and get Desmos to either do this properly using derivatives, which I think would be fun, or we can try to visualize other flows, switching back and forth between Miro and Desmos. Let's do a poll. Poll management. Polls are a great way. What next? We can do other flows, bracket S. And then the other option is partial derivs in Desmos. And then maybe an option is aerofoil. And looks like there's a setting I've got for this that allows Maria extra additional votes, and everyone else, but Maria in particular saying, what do I do with points? Additional votes if you pay channel points, but that feels weird, so I'm going to not do that. Let's just have this go for a couple of minutes. Good, okay. Good, okay, there's a poll. With a particle at -10, yeah. So the particles over here are a bit doomed, right? They're all looking at, they're all moving straight towards this point here. There's a little calculation you can do that says, okay, the ones just above, they get to go away and become maybe this point over here that's going around the circle, points on each side. So kind of there's theoretically, it's theoretically extremely narrow, but still, what's going on along this line? I think it takes infinite time for a theoretical particle approaching the perfect midline of the sphere, the circle. I think it takes a particle infinite time to actually get there. The calculation is not particularly hard. I'll just hit this. We know the flow field now, if you believe me. So we're on x equals 0. Then we've got like a diffraction. Nope, sorry, on y equals 0, because Leroux was interested in what was going on down there. This is like -x squared over x to the 4. It's -1 over x squared. And this is kind of the horizontal velocity. So u, which is like slight abuse of notation, but if you start saying like, so u is like the change in the particle's position over time. That's like -1 over x squared. Which I think you can integrate to say, aha, this is like a separate, this is a differential equation that you can like separate out, and you end up with like x squared dx dt. This one. So this thing is x cubed is, oh, I think I've told you a lie. I think this is going to be, yes, this is going to hit, wait, what have I done? Have I done this wrong? Other Flows has won with 86% of the vote. Ah, good job, Twitch poll. I'd forgotten I was doing a poll. Do I dismiss it now? I dismiss it. Yeah, okay. Nobody wanted me to put partial derivatives into Desmos. Okay, Other Flows. So, I think I told Leroux to lie, but I'm going to leave it as homework. I'm going to look at Other Flows. There are some that are just like vortex kind of flows where things go around and around. They're not very useful for like the flow past a circle, but we should have a look at them. They work like this. Oh, kind of a bit sad to delete all of this, but whatever. They look like this. Ah, this is great live code experience. I need to get rid of all of that previous stuff. And subscript, please, Desmos. Which, ooh, that's quite trippy in its own way. Can you see a tilted square? It's not really there. So this has already got things that are quite large. Oh no, this is going to be really awful. This is going to be horrible. Yeah, okay. Whee! Emergent art. It's tilting because this is a rotation. It's rotating around. There's a little bit of distortion because if you really rotate an object, then along the way its velocity changes on the way around. That sounds really stupid, but on the way around, as the point moves, it turns. And my arrows here, like this arrow on the outside, is not turning; it's just getting longer. So the kind of illusion of smooth motion when really it's just doing at each point in space. But this is called solid body rotation, where the velocity is kind of proportional to how far out you are. It's a bit annoying that this is buried so far down here, but anyway, the velocity is kind of proportional to how far out you are, and that gives you this rotational flow. Yeah, so the base of the arrows, the points where I started, of the grid I made, and this is showing you how the grid could rotate. Fluid dynamics can do this, right? Your bucket of fluid, bucket of water or whatever. If you rotate the bucket and it all goes with the bucket, then well, on the way around, this is what you get. Of course, that's not quite what actually happens when you. It's not quite what happens when you actually rotate a bucket of liquid. That's very bad, by the way. This is very bad. Yeah, it's very bad. If you're watching at home, remember to save your work. What actually happens is something that depends on distance in a slightly different way. Yeah, devastating. I feel like we should maybe go to an ad break. Fine, I'll save my work, right? It's cool, just took an hour and 10, right? Hour and 10, but we learned the good way of doing it, right? So you get a chance to code it again. This will be easy. This will be easy. I can even do this while talking, I think. So, something I'm interested in is, along the way, when you're learning applied maths in university, you learn loads of stuff, and I really like the way that, along the way, you meet lots of these solutions. You never quite get to visualize all of them. So something that I actually want to do is to try and visualize things a bit more. Right, why is that not done anything? Where XA is the number 0. Oh, because this was supposed to be the list. Somewhere in here there's supposed to be an N. Rewind the stream. What was I doing? It's fine, chat. Maybe my ambition to do this while talking at the same time is not going to follow through, but you know. Okay, so we now got some helper things that have not worked, but that's good. Because I didn't do the right thing. Yeah, I want the N up here. There we go, grid. Brill. So this should subtract, instead of being the number 20, by the way, it should be number M. And it's going to be hard-coded to 20. But we're going to subtract M over 2 from both of these. Good, okay, we've got our grid back. What else can we do? And hang on, that goes minus 10, 9, so it should maybe add 1 over 2. Didn't do that last time, see our code's going to be better this time. And I'll log in and sign up. Okay. Log in and save it. Good. We did crash Desmos. Hi, that's Nash. You've just got here after. You just got here after Desmos crashed, and I hadn't saved my work for the first hour and a bit. Arrows crashed Desmos. We'll try and draw loads of arrows in Desmos all at once. It doesn't like that very much. I want to give these things better names, I think. I can't remember why I put subscript A on everything. I'm going to keep doing something like that. Yeah, I always don't want to call them XA and YA for the X of the arrows and the Y of the arrows. But then what do I want to call these? I guess I want to call them UA and VA for the components of the velocity. And they might depend on XA and YA. I guess a question for people playing along at home is, why did Desmos crash after showing the animation several times? Was it using more and more memory each time? Seems a bit unlikely. Right, we're almost back. Yeah, giving these things better names, that's a good idea. Because now I can remember that the U's go with the X's and the T's go with the V's. So it's a lot of interesting things along the way, doesn't it? Why are you like this? Why is it like this? Very exciting. Not quite what I asked for, but you know. Why has it done that? Why are the XAs and the YAs not even correct? This is now a stream about rebuilding things that you had before. Yeah, what have I done wrong? Why? Would be a good emote. Ah, this is very sad. You don't know what you've got till it's gone. It's T plus, not T times. There we go. So now on top of the points, the grid of points, we can put these little arrows. They're not quite arrows yet. Not quite arrows yet, but we're getting there. Let's quickly design a Y emote. It's going to have to look like this, right? It's going to have to be like... Oh, no. Should it be like question mark, exclamation mark? It's got to kind of be square. So the thing about emotes, they're all square. Maybe it could be like underlined in like a exciting way. I don't know. Okay, emote designed in Miro. Brilliant. Cool. Homework, rebuild it in Desmos. Something we were playing with before was sending this from 0 to 0.1 or something with an animation, which crashed the stream before, but you know, we try our best. And that gives this kind of trippy effect of looking like a fluid flow on the way around. Especially if you set that to a kind of blue colour. Up the line thickness. Call it a day. Nice rotating flow. Good. Send it one way. Save. Because this is the sort of thing that it doesn't like. Okay. Okay, we're doing all right. We've got UA and VA. Maybe this is the time to teach it about other things. So there's this other one you can do, which is like this, but divided by r squared, I think. Never going to get old the way, as soon as it sees X, it gets so excited that it's not even letting me type the next letter. Maybe there's a way to stop Desmos from drawing until I'm really ready for it to do the drawing, because it's a poor little thing. And I think I want to show this one only for this one. Again, it's a restriction we've added a few times to if you've got weird stuff going on near the origin. I'm going to bring this slider up to the top. It seems to be quite important that we set this to something realistic. So this one's a bit harder to see, especially if I don't get the parameters right. It's doing a lot more flow near the middle than it is around the outside. Whee! It's really highlighting that kind of octagon we've got near the middle. And I've remembered before we zoomed in the points to kind of bunch them together a bit more around the interesting bit. So I'm going to try and do that as well. Let's take my x coordinates and divide them all by, well, I guess that's 9.5, which is something like m/2. So I'm going to divide them all by m/4, I think. Is that a bit too harsh? We'll find out in a second. Yeah, this has gone a bit weird, but hey. Still too much. Still quite a lot. That's all right. Might have zoomed in a bit too much. This kind of motion of different amounts of velocity at different positions. And this is more like what happens when you start rotating something in fluid. You can set up this kind of irrotational flow. I think it's not the occasion to teach people what irrotational means, or to look too closely about whether or not I've got this right. I've got squares down there. Why have I got squares down there? It's really weird. Let's try not having squares downstairs. Oops. We do want that to be downstairs. So different power downstairs. Yeah, okay, so it decays off at a different rate. I think I might have zoomed in too much. What do people want? People want me to save. Thanks, chat. Look, we rebuilt it in like 10 minutes. It's pretty good. We don't have the arrowheads back yet. I kind of missed the arrowheads. Mountain Ash, do you want arrows? They're not quite arrows yet. I think it was more fun when they were arrows. I could probably put the arrows back in. Let's get a kind of rotation fly. What else can we do? We can do loads of things. There's this kind of hard condition to work out whether this actually represents something that fluid can do. Fluid is incompressible, so which you kind of have some intuition for, that you don't get these points where all the fluid flows just going together and disappearing somewhere. So I think I want to look at other functions of theta. We've got this way of generating solutions. Why? We've got this way of generating solutions because it's cool. Where we look for functions, and this is a bit hard to explain really because I'm using loads of notation, but we're looking for functions that satisfy the Laplace operator of phi equals 0, and then we're using dphi by dx and dphi by dy. In case anybody cares and they know lots about partial derivatives, that ensures that the thing is incompressible, while also being irrotational for fun as well. So there's lots of solutions to this equation. It's really brilliant. We're looking, because of the circle, and we're looking for kind of flows to do with the circle. I've been putting in things to do with r and theta, which has pluses and minuses. One of the upsides is that we get to and the upsides is we get to have these nice things involving circles. One of the downsides is we've got to think about circles, which involves r and theta. Okay. What are we doing? So we're going to look at 1 over r d by dr. So if I look at phi is r of r, theta of theta. This is a trick that people do sometimes to imagine that your function, we talked a while ago about a really basic function that just depended on r. A kind of basic class of functions is to have the dependence on r and theta kind of separating out into these two unknown functions multiplied together. This is still not the most general thing. This doesn't include stuff like r squared plus theta squared, but you hardly ever want something like that with r squared plus theta squared. You can discover lots of interesting functions just by looking at multiples of r dependence and theta dependence. This is called looking for a separable solution. I've spelled separable terribly there, which is the whole point of writing this, I think, but never mind. So what would this be? So I've got, this is the expression for what the Laplace operator is if you're talking about circles or cylinders and you've got r and theta around. What do I do? So these r derivatives are going to ignore capital theta, and these theta derivatives are going to ignore capital R. That's kind of the idea, I suppose. And then what you can do is you get down to this kind of situation where it's not too bad. I've seen worse, where you get kind of this sort of thing multiplied by, I always prefer to have that term first, so I'm going to write it over here. Multiplied by capital theta, and you get this sort of thing multiplied by some derivatives of capital theta. We've tried this out with theta equals 0. We got this kind of explosion outward thing. That was from solutions to this, where we were looking at, and it's hard, it's a little bit tricky because I've got to do the derivatives as well. But that was the ones that just went straight radially outwards, I think. And we've looked at ones where big theta is just cos of theta, and we said that was quite nice because after two derivatives you got back to cos theta, so it kind of cancelled, and you had a chance of setting this to be something or other. In general, you could try setting big theta to be cos n theta for some value of n, and then what you would want as a result, you see that's when you do two derivatives you get almost back to the same thing, that minus n squared out the front, right? So you would need, you're not quite done because you need this thing and this thing minus n squared r over r squared to be 0. But you can solve that in a kind of similar way, right? We did something like this a second ago. You try r to a power, and it just falls out really nicely that you get something like this minus n squared. And I think, oh, brilliant, this is actually really nice, right? This just says that k squared equals n squared. So k should be plus or minus n. So you discover these lovely solutions, which look like r to the n cos n theta and r to the minus n cos n theta. And these are pretty good. This includes all the things we've looked at so far. So if you want other solutions, I've got to show you some more of these for different values of n. And the higher the value of n, the more beautiful these are going to be, because they're going to depend on theta a lot. Yes, these are highly related to ideas about complex numbers. If you're thinking z to the power of n, the back of your head, or z to the power of minus n, these are highly related. Yeah. Essentially, excuse me. Let's not go too much into this, but you get solutions to this equation for free if you know any complex functions. Because if you know a complex analytic function from like c to c, which is like, for example, z goes to z squared, then you can take the real part of f and the imaginary part of f, and they both satisfy the Laplace operator. So you can kind of farm solutions to that differential equation from just thinking of complex functions. That's probably the best way to do it. But you know, this is the first way that people learn to do it, by doing these painful derivatives to do with circles. This is much better. Probably I should have just told you, z to the n, take the real part, you're done. The other one's the real part of z to the minus n. Yeah, it is, I think. So yeah, complex numbers, correct. A while ago, right, I said this one, when you see this y squared minus x squared, it's minus 2xy. So I'm going to do the complex numbers. That might have helped me to realise that there should be a minus sign, because complex numbers would be more like x squared minus y squared. Anyway, never mind. If I'd been paying more attention to the stream, I might have realised what was going on. There's a disclaimer, by the way, on the Twitch page, just underneath where you're watching on my page, that says, "Don't worry, I'm not going to talk about fluid dynamics." It's a lie. I talk about fluid dynamics all the time. But using complex numbers a tiny bit, so that's good. Okay, I think my aim is to show you these for larger values of theta. They're fluid flows that we can talk about how you might set them up. This one is really exciting near the origin because it just gets huge. My Desmos plot is not very good for that, so I think I'm going to restrict to looking like for r bigger than 1. That first one we might get away with it. Let's give it a go. Here's the problem. My code is built to you want the x derivative and the y derivative of these things. So I think what I really need, unfortunately, this is going to be awful, because the cos n theta, how am I going to do this? How am I going to do this? How am I going to do this? These are in r and theta. And my Desmos thing that I built really quickly twice wants x and y stuff. It's kind of asking me to translate it back into x and y. But that's a real pain. So instead, I think I'm going to clone the Desmos page and teach Desmos about r and theta components. And that'll give us a different way of doing this. So that instead of doing, oh my goodness, what is this horrible stuff? Hey. Instead of doing all this horrible stuff with x and y, I can just show Desmos, you should plot, instead of looking for the x and y components of the velocity, I'm going to tell it what the r and theta components are, and that's fine. That also specifies the velocity. If you tell it, instead of the x and y coordinates, if you tell it components, if you tell it the r and theta components, everything's fine. Sorry, this hand is doing coordinates, this hand is doing thumbs ups. They're kind of pretty similar. If you tell the coordinates, that's fine. And we can calculate those from our phi over in Miro on the whiteboard. We can calculate those from phi and then just feed them into Desmos. What we'll need to change is this bit where it's adding the components. That'll have to be a little bit more clever, because the components bit of Desmos really wants x and y components, I think. I'll have to do some resolving of things there. R component and a theta component. Yeah, there'd be some trig down there, but it's going to be okay. It's going to be okay. He says to himself a lot. Okay, so we're going to teach Desmos about how to plot little vectors where you're given the r and theta components. After you finish this, listen to what it sounds like. Can you even play the sound of this? Will it let me? It won't let me do the sound for a plot like this, which is a bit sad. Okay, save, duplicate, flow, r theta. We're going polar. Where we're going. Oh my goodness! So what's this going to do? I think it should calculate r and theta first. So for each point, we'll need to know what the value is for RA and YA, which is kind of a good helper function that we should maybe have defined already, right? Because we have all of these things in here, which would be much nicer written as RA squared. So that's pretty good. Oh, I like the way this is still working. So it's a bit like doing surgery while the thing's still going, right? And then over here, I think what I actually want to calculate is not the u and v components, but the r and theta components. Oh, it's not going to like this. Yeah, it doesn't like this. Okay, I'm not allowed to call it RA and TA. Maybe I am. Maybe I'll get away with this. R and theta components, which have got some sort of expression. I think at the moment, this one is 0. Oh no, it really doesn't like this. RA, it's also got opinions, right? Let's try to set that up with the slider and stuff. Okay, wrong variable name. I need 2 letters. It's annoying. Desmos does know about polar coordinates, right? It has like a... It does know about polar coordinates. Should I be using these? I'm not sure I can plot points in a grid like this. Do I even want to do a grid? When the dust settles, am I going to regret the grid setup thing? There's not going to be less than 0, don't worry. Yeah, I've already used RA for the radial values of the points. I should do TA for the theta values of the points. Is it going to be happy with that? Yeah, it's kind of happy with that. That's all right then. So you could write things like y is r sine theta. And you could write things like, oh, I didn't like that at all. Y arctan y over a. Why didn't it like that? It was doing so well before. Y should be r sine theta, right? Quick intro to polar coordinates. It's a way of describing where stuff is, where instead of talking about x and y, you talk about r and theta. Theta for the angle above the axis and r for the distance out from the axis. You can convert back if you need to because of trigonometry, which says that x is r cos theta and y is r sine theta. Now what I hoped would happen if I typed in here, this y for the arrows, that I could just replace it with an r sine theta. It didn't seem to do the right thing. This is a sign that I've messed something up so far. Desmos does have theta as a character. It also has strong opinions about theta. I think. Oh, not so far that it'll. Not so far that it'll. Why has that done that? Oh, is Arctan weird? Arctan's weird in Desmos. Arctan's weird in Desmos. Arctan's weird in Desmos. How are we going to get around Arctan? It's flipped everything over there. Everything's going to be backwards on that side. That's really annoying. I'm going to have to teach it what I mean by... Yeah, so it's not quite going to be right. It's going to be like a... Oh, we got away with it? No, not really. It's doing something really weird as it goes round. Because what does Desmos think arctan of a... What does Desmos think arctan of a negative number is? I'm always scared to ask. Negative numbers? Yeah. What's your deal, Desmos? Wait, what? Okay, I don't really know what's gone wrong anymore. this was perfectly happy as a YA. And this was perfectly happy as an XA. We had this nice circle thing where each point would go around like that. It's all very nice. But then as soon as you change it to the equivalent expression, it's going to be the arctan that's the problem. If you're telling me in chat that the arctan is the problem, I'm pretty sure that is the thing. It's just not happy because now all the points over there on the left are going the wrong way. They're going like exactly the wrong way. The x component is exactly wrong. It should be... It's like I've got a minus sign wrong. Because as I cross over, what do I actually want? Strong opinions. That's how I like to phrase it, but, you know, I'm nervous about using the theta symbol because Desmos might, at random moments, start interpreting it as angle, which it kind of is. Also, you've got to type the whole word theta. Why can't we rebuild this? So what are we looking at? We're looking at a point where x is negative. I don't want arctan 2. It doesn't have arctan 2, does it? No, okay. Some languages have got two sorts of arctan. When this goes negative, it's doing negative. Oh, and it's forcing that to mean that when I put the negative numbers back in again. Gosh, I used to be so much better at this sort of thing. Yeah, minus y over minus x is the same thing as y over x. Yeah, so we can't reconstruct what the point was from the given values of RA and TA. Yeah, there should be a sign of... Can I fix this with like a sign of x in here? Ha, yes. Fixed, what a hack. Does that work down here as well? Yeah, what a hack. Brilliant. Can teach it how to do arctan 2. Oh, I'm really pleased with myself. Yeah. Little sign of x in there so that it reconstructs which case we're in. Ah, Desmos hack. Good. We taught it the proper sort of arctan. Good. Now we're free to switch all of these things for expressions involving RA and cos TA. So we're getting a bit closer now. I almost said really close, but that was overexcitement. So we have like interesting things like this, where we can now cancel a factor of RA. And look how much simpler that is already. Ah, why has it done that to me? Why do you do this? It's done the minus sign again. It's like I don't want the sign. Oh no, it's gone bad. Sign of both of them. A bit of a Hail Mary. Hail Mary failed. Bonus minus sign. Yeah, again, now just guessing. Just undermining the thing that I was trying before. Ah, this was really good. What? And then I cancelled some factors. Maybe I introduced a minus sign while I was doing that. How much can you try and Z in this? Oh, is it actually problematic as soon as I put this TA in? Yeah, it was actually problematic as soon as I switched the other one. I don't think my fix worked as well as I thought it had. I don't think my hack worked as well as I got very happy about the hack. But actually this is not quite how this works, is it? Okay, we're teaching Desmos about arctan, teaching Desmos about arctan. If, what do I want here? If XA is positive, then carry on, please do arctan in the normal way, and it will get an angle. Just want to calculate theta, right? To be something between minus pi and pi for all of these points. Shouldn't be that bad, right? Something between minus pi and pi for all these points. Yeah, so it's just sine of YA, right? No, why is that not just sine of YA? Calculating theta for all my points. Oh, was it actually returning for... Is it returning things from... What's the range on Arctan? What is the range on Arctan for Desmos? New Desmos. Well, okay, that's what I thought it was. So, right, okay. So when it... This is classic polar coordinate confusion. And then why the other? So, of course, suggesting that I pepper sine of x everywhere, which I don't love. I kind of want to just get the nice clean solution of get the correct values of r and theta up here, and then just treat them like normal for the rest of my life. How am I going to do this? So when x and y are both positive, it's fine because it returns a positive number, and I want a positive number. When x is negative and y is positive, when I'm in this quadrant, it sees a negative number and it returns a negative value. Rubbish. I wanted to add pi in that case. So if... I might change this slightly, but if x is... Oh, this is so clumsy. If x is negative... I wanted to add pi sometimes. I wanted to add pi. Because over here... Yeah, let's be really clear about where I wanted to add pi. So my calculation using arctan. Arctan is such a weird function. Arctan's really weird. Over here, it's returning arctan positive from like 0 up to pi over 2. And over here, it's returning arctan negative from like 0 down to minus pi over 2, which is just what I wanted. It sees a positive input for y over x. Everyone's happy. Something like this, yes. Over here, it gets confused because I want it to keep going from pi over 2 up to pi, but it sees a negative value of y over x. And it tells me that it's going to be arctan negative in that case because I'm putting in a negative value of y over x, and that's how arctan works. So it's going to return immediately here like pi minus pi over 2 up to, up to 0. So I want to, in that situation, I wanted to add pi. Add pi up here, I guess, would be my fix. And over here, it's doing something similar. It's doing pi over 2 down to 0 over here. So over here, I wanted to like subtract pi. Subtract pi, maybe? Would I be happy with adding pi? So it's out by 2 pi. New. Hey Zoe. Good, thanks. We've had some ups and downs. We've had some successes and failures. The stream video on demand VOD is the only record of the good bit where we had arrows working because I wasn't saving my work and Desmos crashed in the middle. We're trying to do fun stuff in Desmos, but I'm trying to solve a kind of mini game about getting a kind of good version of Arctan that actually behaves in the way I want when I give it y over x. It's a function that I think in some programming languages is called atan2, which I can't quite remember how it works or what it does, but you know. Can I just add pi on the left? Yeah, I think I just want to add pi on the left. So add pi if the sign is... Oh, this is clumsy. This is clumsy. This is really clumsy. So add pi if the sign of x... Back into the thing. If x is negative, add pi is my little fix. Little fix. Yes, I've heard a lot about forward summary. Arrows fluid flow crashed. Yeah, the font's really great. It's got some really nice fluid flow stuff in it that we have no access to anymore because we lost the Desmos. I've heard Advent of Code is just really hard every year. If it's your first year of doing Advent of Code, welcome. It just gets really horrible really quickly. I've never tried, so I guess I'm not allowed to say welcome. But yeah, it doesn't surprise me. I think anecdotally, I've heard it's also harder at the weekend. Somebody out there may be setting questions. Thinks do you have what time of the weekend? Ugh. Did anyone see like a ghost appear very briefly there as I tried to get Desmos to do this? Yeah, I was really happy with this. Can I use anything? Fine, okay. Well, let's do it the hard way then. So like the sine of xa returns a number that's either 1 or 0, either 1 or minus 1. I don't want 1 or minus 1. I want 0 or 1. I don't even really want 0 or 1. I want minus 1. Right, what does this do? So this is 1 minus sine A is 0 on the right, brilliant, and it is 2 on the left, not great, but we can fix this by multiplying by pi over 2. Whew. Okay, so this little helper function, extra bit, is adding a very specific correction to explain to Desmos that fine, I asked you to do arctan of y over x, but actually I've got a slightly different opinion. That's going to mislead you. For on the left of the picture, it's not quite what I wanted. So I add this kind of correction thing. Sine of y pi. Yeah, that would also work, I think. You're going to add a pi up. It kind of jumps when x is 0. So this expression is really bad when x is 0. It's just not behaving well when I cross over that line. So I've got this kind of fix which explains to it to work out which side of the line it's on, which side of the x equals 0 line it's on, and add an appropriate correction to the value of arctan. Good. Right, now we never have to think about that again. That's the advantage, right? You do it correctly, and then you never have to think about it again, because now you can do things like this, and it's just fine. If you've just joined, we're doing this kind of nice animation thing to try and demonstrate some fluid flow. What happens? Desmos is the right place to do this, I claim, because it lets you do this kind of animation live while you're working on it, which is pretty good for different points in space. Earlier we had some nice arrows. I've got this 10 to 4. I would quite like to rebuild the arrows. They were cute. But right now we don't have any arrows. This is demonstrating a flow that's kind of different circles rotating at different speeds. It's an irrotational flow. It's kind of good. Right, okay. Running out of time a little bit, but I want to try and show you. Yeah, we were going to put in the components. So at the moment it's using X and Y components for these little arrow line segments. X and Y components, but it could be using R and theta components, which I'm now going to try and do. It's going to be awful. I'm going to give them names, MA and NA, why not? I'm just going to, those are the worst possible letters to use. Let's try harder. I've already used U and V, so next one's a W, and X, W and Z, whatever. Okay, Y and Z. And now these functions should be something like trying to keep track of what the radial component is and what the yeah, these are good. So this needs to be this. So that actually, if you just put in 0, it will return the number 0. If you want 0 for every point, the trick is to multiply by your grid, so you get this 400 element list. And then I guess the thing that I want is not quite this, but it is, oh gosh, it's a little bit complicated. Here we go. Because it's going to need to be the X component. So to get the X component out, I need to think about the R component. The R component times cos theta. Oh my goodness, which is TA in this world. And the theta component, which I've called ZA, times and then sine TA. Professional level coding, absolutely. It's very broken at the moment because it's doing mixed things about this. So then flip it around to the Y component, which I think is this. And that's a mess. That's a mess. That's worse. So there's now the part of the string where we just sort of put extra factors in. Well, we've made a kind of explosion. Thank you for joining me for the last 2 hours of making Desmos pictures. I'm not going until I fix this. This is awful, isn't it? It's really bad. Who allowed this? Why is it done? I haven't got the restrictions on. I haven't got any restrictors on. That might help. Might help. Okay. Take off the restrictions. Still looks like we've got some minus sign errors. But these black lines are something to do with the blue lines. The new black lines are something used to the blue lines, but they're definitely in the wrong direction. So that's fun. So theta component. Yeah, you just take the theta component, right? Sine TA, and then flip them on the other one. Yeah, this is like resolving forces. If you've had to do a mechanics unit, you know about resolving forces. I'm trying to resolve a component into its x and y components. I've got all of the signs wrong, I think. That can't really be true. All of the signs wrong? So I've just been working on this thing where it's got like a little component in that direction, which should just be cos theta and sine theta, right, with the components. Oh, so you throw in the cos theta term over here and the sine term over here. Yeah. And meanwhile, I've got a theta kind of directional component, which should be like a minus. Ah, there's a minus sign over here. Minus sine, because it starts at 0. So this should be minus sine, and this should be plus cos. We're going to get there. We might have got there. Are those the same? They're now in the same direction. The scale's all over the place. I'm not certain I put it in the same function. Ah, this goes up to 1, and it should go to T max. They're the same! Chat, we're now in R and theta. We're now in R and theta components. Something exciting has happened. Because I can now copy across the settings on those lines, delete the previous ones, delete the UV components, and I've now got, delete that because it's not even been plotted, I've now got a grid at the top, pretty clumsy modular arithmetic stuff to set up the grid, calculate R and theta from that grid, and now just give me, this could be an RA as well. Oh, isn't that nice? We're plotting outside the circle, so RA bigger than 1. So it's now just looking at the components. 0, kind of weirdly multiplied by RA, but look, 0 base, fast time. 0 for the 0 radial component and some theta component, which makes a lot more sense as a way of describing that flow. To say there's no radial in and out flow, but there is some theta flow. Okay, we're really getting there. Let's do a cos theta one to try and rebuild some stuff. Before we were looking at r cos theta, which the components I need to tell you now I need to work out these things for the components. These are, I think, the thing I've been calling WA and ZA, or possibly the other way around, but hey, which would be just cos theta and 1 over r divided by, so this would be divided theta. So this would be sine theta minus sine theta. So this is kind of quite nice. This will be the just horizontal flow, I think. So I type this as cos theta using my notation for theta, and this is minus sine theta. We get to something that we saw earlier today. Which is the everything just flowing sideways flow. But here, a bit of work to do it. Save? Yeah. Plot r equals 1 as the circle. Yeah, we're going to get back to the circle. Good. Stick this back in. Good. Save. We've got a circle. Flow's not going around the circle, it's clearly crossing the circle. That's pretty annoying. Don't want that. Flow going through the circle. So we can go back to that one we had before, where we saw the fix was to add in a little bit of 1 over r cos theta. We saw halfway through that these powers are plus and minus. The plus and minus the number in front of theta, which here is 1. So this looks like the r derivative would then be minus 1 over r squared cos theta, and the theta derivative divided by r would be 1 over r squared minus sine theta. There's kind of this extra factor of 1 over r in this. Partial derivatives in polar coordinates are just a bit weird. You kind of need a 1 over r so that the things kind of balance out the powers of r everywhere. Makes it make sense. Which is pretty easy. It means I just divide these by ra squared, right? Divided by ra squared. Oh, no, didn't like that. It tried to do subscript ra. Subscript r squared. Okay, and that adds just a little bit of deviation. A little bit of deviation, not very much. So this flow is pretty subtle. Has that worked? It looks horizontal to me. Is it horizontal? Have I put zeros in by mistake? So ignoring my ZAs, we'll find out. Why is that going so horizontal? Why does this say r equals 1 down here? Oh, because that's Desmos has recognised that that's an equation in polar coordinates. Why are the blue lines so horizontal? They weren't horizontal a moment ago. Not convinced. Kind of some dependence there. Got my cos and sine correct? Yeah, I think we're good. I think we're good. Yeah, look, I'm just going to do the first one, take away the second one. Easiest way to do that is to bring it out here. Let's do sort of 1 minus 1 over RA squared. So there's a thing you can do where you combine the flows together. The equation is linear, so you're allowed to add stuff, and this gives you this kind of interesting combination. Interesting combinations of what we live for. So this one was then sine TA, and I'm a little bit suspicious about whether this is going to work or not, but hey, if it looks like it's working, then I'm going to call it a day. And instead of that, I want 1 plus, and instead of that, I want a electrical field. Anybody? Oh, minus signs on both of these. Yeah, there we go. I think we might be back. To flow around a circle. There we go. Flow around a circle. Very nice. Get the go. Whee. Not certain I've got all the terms right. Yeah, it's not 1 over r squared, is it? Maybe it is. 1 over r squared for the velocity. Maybe it's deviating quite a lot up there. Yeah, what's this far field like? Far field should be fine. We're quite zoomed in. Let's zoom out a bit. No, that zoomed in more. I will work that out at some point. That should be a parameter. Yeah, I'm just surprised that there's so much deviation in the flow. Do we have that before? I might have typed it wrong. I might be scaling poorly. Woomph. There we go. So you can see how it kind of, assuming this is correct, which is not a given. Assuming this is correct, you can see how the flow kind of, yeah, there we go. Okay, so the far field. I want to check the far field. Yeah, that's all right. Okay. I'm less worried now. Far away, things should be just going past the circle. But nearby, you get this kind of flow around the circle, and you kind of see that it speeds up a bit in certain places, slows down in certain places. So okay, let's zoom back in. I'm now convinced that maybe I've typed the correct things, and that this can maybe flow past. Yeah, change the max number. Woomph. Lovely. Going back to hit 4 o'clock. I promise you a 2 theta thing, I think. Just to wrap up, we're going to have a look at r squared cos 2 theta. So if phi is this, then I still need to work out defined by r and 1 over r defined by theta, which is going to be minus 2r sine 2 theta. Quick check. Minus 2r, because I did the derivative, I got the minus from the cosine, a 2, and I divided by r. For the other one, I did the derivative. I'm going to ignore the factors of 2 out the front, because that just makes everything twice as large. So I'm going to plot r cos 2 theta for my radial component, and I'm going to plot r sine 2 theta with a minus sign for my theta component. Right, okay, let's type those in. So in here, I'm going to go r, and I said cos 2 theta, and in here, r, and I said sine 2 theta, and I said minus sine. Aha, there we go. This is a flow that I've seen before. Let's take off the safety rails, because this one's nice. So this one describes, yeah, this one's a bit weird. There we go. So this is incompressible. It's the thing I warned you about, where fluid coming towards each other, right? It can't just disappear in the middle. It's incompressible. It can't be squashed, so it has to get squirted out the sides. Whee, there it goes. So this is sort of driven by, This one's different from other ones we've seen. It gets larger. The velocity is getting larger further away. It's what you get if you have a system with some wheels far away, stirring the fluid in counter-rotating wheels. For the normal way to do is 4 counter-rotating mills. We have a little square of 4 circles, and you can set up this flow at the origin by fiddling far away, very, very far away, off the edge of the screen, and there's something stirring this to get fluid to come in and then straight out. Good, okay. I think we can do better though, because I think the 1 over solution is actually nicer. So let's have a quick look. If I do r to the minus 2 cos 2 theta, what does that actually give me? So if I do the r derivative, I get r to the minus 3 cos 2 theta. And if I do 1 over the theta derivative, always the hardest one to think about, I get minus, still 2, cos 2 theta with a minus sign and a 2. And I dropped a minus 2 over here. So now I'll get a minus sign on the first thing, which I should try and remember. And I think I'm going to go back to banning the inside bit for this one. I'll draw the circle, why not? So what was that? That was cos 2 theta and sin 2 theta again. But now there's a minus sign, and this is the power of minus 3. And over here there was a minus sign, and this is the power of minus 3. I think that's what we were talking about. Yeah, these things that decay like 1 over r cubed. Okay, can't really see what's going on from those little bits of arrow. Let's try animating it. Oh, this is hard to explain. I'm not sure I can see what's going on. I don't like the circle for this. The circle is not relevant. I'm going to put the safety net. Oh, it's quite large. Quite large over there. The thing is, there's a resolution question about if I just let the arrows grow and grow and grow, right, then it stops being accurate because you've got one massive arrow crossing across the diagram, which wouldn't do. An actual particle following the flow would move things around. The goal for today was to show different fluid flows. I think we've got that. So this one is doing, yeah, it's impossible to see. It's annoying. A bit more resolution, I might be able to show you what this one looks like. There's some tweaking, some parameters to tweak here, right? Where I zoom the points a bit closer together. I never remember if I should make this number smaller. Yeah, smaller. Density of points, and then make them much shorter. Yeah, okay. So this is doing some counter-rotating eddies, but loads of them. So in each quadrant, there's something happening in each quadrant. You can't see. I've got to make this stop so early. Yeah, you can almost see it, and then they cross. I don't really want the arrows to cross. So these ones with the negative powers are so much larger near the origin. But maybe you can see that this flow itself decays far away, very small far away, very large near the origin, and it's doing these kind of counter-rotating eddies. It's quite hard to see. Quite hard to see. And I don't like the way they're crossing over. I don't like the way they're crossing, because like a real particle starting here would do this proper thing. The trajectory is, I think, something like, where's the trajectory? Just the trajectories are streamlines are in this case nice eddies. If I had a lot more time, I would then plot the kind of traces, and these things are moving along particular lines, which you can also solve. We're doing theoretical solutions here, so we've got control over everything. We'll also try and show you those. Saving reminder, good. But I think I'm going to set it all back to flow past a. I think I'm going to set it to this. These are quite hard to visualize. No, but it's fun. It's fun, isn't it? Go with parameter n. I know this is a total mess. But if you put an m flow inside here, and here, and here, and here, won't actually let me type mflow -1 upstairs. Here and here, then you can make these other ones. And for higher values of n, it's even more. Lots of flow near the origin, less flow further away. But you get these ones with even more structure, even more counter-rotating eddies. And it doesn't look like it's making any sense because they're all crossing over. Still trippy. So I think I'll set that back down to... This is supposed to be an integer for reasons, but I think I'll set this back down to 1. So that we get this nice flare again. Okay. Do we have this before? Somehow it looks much better than the one we had before. Oh, we're now inside the circle. No, what's going on? I think I might have screwed up some minus signs. Ah, well, we tried. Right, thanks for playing along, chat. Sorry, this one was mostly me trying to make something work and not entirely getting it to work, but you know, it's almost like I've just brought work to the party rather than. I love the way that's showing the deformation. Actually, I think that's really neat. Yeah, I've got something now seriously wrong. I broke it, chat. Save. Good. Okay. What's that? Someone. What's chat saying? Save. Someone brought tea time. You could use a teaspoon to get the same effect as those 2 items. Yeah. Stirring. Would have had the same effect, I think, but I wouldn't be able to rewind. Watch it again. Why has it done this? I swear every time I plot this, it looks different. I think I'm being a bit daft. I want those to match and these to mismatch. Not 9 plus. That's what I want, right? And now it's going right to left. And it's so huge far away. What have I done? Ah, this is R, not RA. Fixed, sort of. Sort of fixed. Not quite fixed. Chat, I broke it. I'm not sure what I did, but I broke it. What am I plotting now? I'm just plotting something random. Oh, are these supposed to be exactly opposite but matching? Yeah, it's that. I've just screwed up all the minus signs. Nothing new there. Flow around a circle. Yeah, very slow flow around a circle. Yeah. Do it again. Yeah. Save. I broke it, but just by putting minus signs in. I stopped being careful about what I was doing. Should always be careful. Cool, right. If you want the finished thing, Desmos, the link is in chat on Twitch. If you want to play around with this, messing around with the parameters, if you want to tidy it up, then that'd be fun. Don't tidy it up. But if you want an animation of fluid flow around a sphere, tracer particles at roughly 400 locations, there you go. I think that's productive. I'm not here next week because Christmas. But I might be doing a New Year's Eve stream. We'll see. Was that my door? Wasn't for me. Good. Okay. Nice to see you, chat. Remember, if you saw an advert, you're supporting charity. It's a pretty cool thing to do. Thanks for doing that. And if you redeemed a hydrate thing today, then I don't know what happens to the channel points. I don't know if that supports charity in some way. I kind of doubt it. But thanks for reminding me to drink water. It's nice to see you again. Have a good December. Merry Christmas to people who celebrate. Happy end of the year, everyone. I think I'm doing a New Year's Eve stream, which is 2 weeks. It's so weird that New Year's Eve is only 2 weeks away. Christmas is only 1 week away. I should probably do some Christmas shopping. Maybe I should not do this, and I should do some Christmas shopping. Maybe this could be a Christmas gift. Will my family accept this? Yeah. Good. Okay. Take care, chat. I will see you in a couple of weeks. Happy holidays. Merry Christmas, all of that. If you're subscribed to the Oxford Mathematics social medias, then I'll see you on Christmas, because I've made some Christmas content that I'm very excited about, wearing my Christmas jumper. It's pre-recorded, so I've already made it. Don't worry, they're not making me turn up to work on Christmas Day. I believe we're counter streaming the King's Speech, so we'll see. It's your choice. I'm doing a puzzle. The puzzle's probably too easy for people watching this stream, but it's kind of for kids. But if you want a very straightforward Christmas puzzle, then we've got a silly one for you on the Oxford social medias. Good, right, okay. Yeah, I learned the word counter streaming recently. Can you tell? I owe you some emotes, right? I owe you the oh no. We need an oh no emote, like the opposite of WoW, which would be really good if Desmos crashed. That would be really good, right? If only we had the oh no emote ready. We need a why emote. Good. Right. Okay. See you in a couple of weeks. Bye.